on to section B. B1. Part A. So what they've done in this question is, if you look, you've got yourself a rectangle, and it looks like they give you the A and the B. In fact, they say that the A is 1 unit out and the B is 1 unit out as well. Can you see that in the information at the start of the question? Yeah? Firstly, to start, they want the slope of AB. So A is minus 1, 0. B is 0, 1. Well, you know the formula for slope, don't you? x2 minus x1, sorry, bad teacher. y2 minus y1 over x2 minus x1. So that would be 1 minus 0 over 0 minus 1. So that is 1. So 2 marks. Part B. The point C has coordinates of minus 2 and A. Find the length of BC in terms of A. So they want to know the length of BC. Do you know the formula for the length between 2 points?
I used to.
Yeah. If you don't know it, you can actually use Pythagoras if I draw it, okay? So if I scroll down a bit, here is the y-axis. Look up, guys, come on. Here's the y-axis, and then here's the negative x. Now here's B. How high up is B? How high up is this point? 1, isn't it? Now here's C. How high up is C? What's the height of C?
Next to A.
No? A. Okay. Now, how far out is it from here to here?
Next to.
So the length, if I just mean the length, is how many units? 2 units. Okay. And what would they like? They want this length here. So if you imagine it as a right angled triangle, how big is the base? How big is the base? 2 units. And how big is the height of the triangle? What's the height of this triangle? No. A minus 1. How high is this? How high is this? Come on. How high is this point?
A plus 1.
A. See, I have it in green and everything, it's A. And how high is this point? 1. So what is the height in between? A minus 1. Alright? If that is 1 meter tall and that's 5 meters tall, then in between will be 4 meters. Right? Okay, so if I use Pythagoras to get this, what's Pythagoras say? X squared equals...
A squared plus B squared.
Yeah, so in this case, A minus 1 squared plus
2 squared.
2 squared. So I get X squared equals A squared minus 2A plus 1 plus 4. So I get X equals square root. So instead of X, actually, let me call it L or something, because it's a length. So I get length equals A squared minus 2A plus 5. So that's the answer there for the second part.
What's the formula for length?
If you wanted to use your formula for the distance between 2 points, the formula is square root x2 minus x1 squared plus y2 minus y1 squared. Now, this formula is not in the formula book, and it's not actually on the syllabus. which makes me think that they probably expected students to do this using Pythagoras, because Pythagoras is on the syllabus, and I think it is in the formula book anyways. But if you knew that formula, I would accept that formula if you wanted to use it. It is acceptable. Okay, can I go on to the C part now? Yes? Okay, so C part. So now, they tell me what the length is. What is the length? It is 2 root 2. Now what is the formula I got for my length? Can you read it back to me please? Square root?
A to a power 2 minus 2a plus 5.
Huh?
A to the power of 2
Yes?
minus 2a
Yes?
plus 5.
Yes. And what does that length equal? 2 root 2. Now we would like you to find the a. So how can we solve this equation? Any ideas? Very good. Square both sides and we get a squared minus 2a plus 5 equals 8. So I get a squared minus 2a minus 3 equals 0. A minus 3, a plus 1. A equals minus 1 or 3. Which do you think is the right answer here?
3.
Yep, because it's above the y-axis, not below in the graph.
So how did you get 8?
2 root 2 squared. Type that in on the calculator. Make sure you use brackets. Reject. And this one here is the one you accept.
But there is no such thing as negative length.
But no, A is not a length now. A is the y coordinate for the point. So that could be negative, it's just not because it's visually in the upper region.
Yeah.
Okay. Okay, can I scroll down now? Yeah? Okay. So let's recap with our points. This point here, A, what is it? Minus 1 and 0. What's the B? What was B? It was 0 and 1. Now, we've just worked out the C. The C was minus 2 and A. And what was the value for A we got? 3. And they would like you to find D. Now you might think this is impossibly difficult. I see you're nodding, Ali.
No, it's doable.
Oh, okay. This is your. So you should have been shaking your head.
I'm
then.
just agreeing with
All right. Okay.
you know?
Well, tell me what to do then.
Yeah, go on.
Now, there's a.
Yes.
Between AC is the same as distance between BD.
Nice.
Yes, but there's a trick here. This question is worth 4 marks, and that's actually surprising to me because it's 4 marks, but you can do it in one step. And I think that you're getting the 4 marks not for your work, but for your insight. Does that make sense? So you're not getting 4 marks for doing work, but just for insight. And the insight is this. Because this is a rectangle, it means B to A is parallel to C to D. And B to A is the same length as C to D. Therefore, whatever rule takes you from B to A, it also applies from C to D. Example, what is the X value for B? 0. And what is the X value for A? Minus 1. So what happens to the X value as you move from B to A? What do? You decrease by 1. Now the Y value, what is it? 1 from B. And at A? 0. So what's happened to the Y value?
Minus 1.
It's decreased by 1. So to go from B to A, you decrease both coordinates by 1. That rule also applies from C to D because they are parallel and of the same length. So, what do you think D is? Minus 3, 2. Finished. 4 marks.
Wow.
Okay, so minus 3, 2.
But what would you do otherwise? Like if you...
Hang on a second there. Let me just write that in. Minus 3, 2. Because, look, the way to move from B to A is to do a minus 1 on both. Sorry, I stopped the recording. I didn't realise there was one part left, so I need to stitch these two videos together. The last part is prove that CD is perpendicular to BC. Well, we just need to look at the slopes, don't we? So, what is the slope of BC? Well, that's this line. So this is now part 3. Here's BC. And then we want to show that it's perpendicular to CD. Okay, so just using our slope formula, it would be 3 minus 2 over minus 2 minus minus 3 is plus 3. So that would be 1 over minus 5. That's the slope. Now let's get the slope of this line. It would be 3 minus 1 over minus 2 minus 0. Is that right? No, something's gone wrong here. 3 minus 1 over minus 2 minus 0. No, that's right. That's 2 over minus 2. Oh, I think I must have done something wrong with this one here. Sorry. 3 minus 2 minus 2 minus minus 3. That's... Oh, what?
Wouldn't...
No, it's not 5. It's not 5. It's not 5. It should have been 1.
Shouldn't have the same slope as AB.
Yes, it should. Where's my pen gone? Come back, pen. Oh, that's not right. Pencil. One. Hang on. I probably want pen. Where's that?
Yeah. Bottom left.
Yeah. There,
Top,
there it
top,
is.
top left.
Yeah, exactly.
Top left?
No,
Oh,
yeah.
1. Okay. So the slope here is minus 1. No, it's not even minus. It's plus 1. Plus 1. And then the slope of this line is minus 1. So to prove that they're perpendicular, when you multiply their slopes together, what should you get? Do you remember me saying this? You should get minus 1. Or another way of checking, which is what we usually do, if this slope is minus 1, then what you say it's minus 1 over 1, and then you do the flip and change the sign. So if I change the sign and flip it, what do I get?
1.
1 over 1, which is 1, which is the other one. So I mean, you can see it's definitely perpendicular. Okay, now I can stop it.